Thank you everyone for being here today. Um, my name is Dr. Jennifer Jamison, and I am the project director for STEM FUERTE. Can we go to the next slide, please? And here's a little brief overview of what I'm going to talk about. I'm going to just give you an overview of what we do and why we do it. And then we're going to talk about key components of the program, such as how we let students collaborate interdisciplinarily, how we strengthen them through skills building, how we prepare them for their life after EPCC through articulation, and then how we help them socially and mentally. And then we'll talk about what's going on for the future. Next slide, please. So STEM Fuerte is essentially, it is a $4.9 million grant that was funded by the United States Department of Education. And one of the things that you should know is that it is a responsive and concerted partnership that exists between EPCC and the University of Texas at El Paso. So we're not just over here by ourselves doing what we do. We actually meet very frequently with UTEP to make sure that we meet our program aims. And one of the things I will tell you is that EPCC, there's STEM Fuerte here, and then there's also STEM Fuerte at UTEP. And so for students who transfer over to UTEP, they would get a chance to take advantage of an analogous type program over there. Next slide, please. Okay. So what is STEM Fuerte? What do we do? Our goal is simple, and we have our mission kind of broken up into three parts. The first part of our mission is academic, and we just want to grow Hispanic student success in STEM education. A lot of students across the country, regardless of economic or racial breakdowns, they intend to major in STEM, but somewhere along the way, they end up not completing their degree in STEM. They transfer to other majors or they drop out altogether, which we call the leaky pipeline. And so our goal is to help students who want to do STEM stay in STEM for as long, for the completion of their degree. And so that's the academic side. The next part of our mission is professional, where we want to prepare students that once they get their degrees from EPCC to go and be powerhouses, whether they continue their education at a Black and Laureate program or they decide to enter into industry directly. And then finally, we want to deal with the whole student. We understand, students are more than just come to class and then go home. Some of them have families already, they're married, children, they are taking care of parents or grandparents, and so our goal is to make sure that students are getting their needs met in a holistic sense. And this directly supports the EPCC mission of providing high quality education and actually ensuring that they have support along their career pathways for their duration at EPCC. Next slide, please. And so our specific program aims, I've broken them down into 4 sections. The first being interdisciplinary collaboration, which I'll talk about extensively, where students get to work outside of their disciplines with other STEM professionals to learn how to communicate and solve a problem. The second leg is skills building, where again, we prepare students to get strengthened in ways that they wouldn't necessarily get just taking a class. So preparing them for the workforce and their life beyond. And then the third part is articulation, which is helping them if they're going to go into the workforce or go to UTEP or even another 4-year institution. And then finally, sense of belonging, which is we'll talk about what that means, but it's basically supporting students socially. So we're going to go ahead and talk about the first leg. We'll go in order. So we'll talk about interdisciplinary collaboration. Next slide, please. So interdisciplinary collaboration for STEM Fuerte here at EPCC involves 3 disciplines: architecture, biology, and engineering. And we put approximately, more or less, 2 students from each of those majors into one team, and then they're tasked with solving a unique problem of their choosing. But I'll talk a little bit more about that coming up. Next slide, please. So as far as having students in classes and collaborating on projects, that is the domain of the faculty co-principal investigators, and their names are Clark Myers from architecture. He's also the faculty coordinator for that discipline. This year for spring 2024, all the way through summer of 2024, we've had Elizabeth Fraza in biology, and then we have Professor Nora Cavalier, who's in engineering. And these faculty work together to help their students collaborate across these 3 disciplines. Next slide, please. So some of the classes where STEM Fuerte has been implemented, it's not in every class. It's not in every class in architecture, biology, or engineering. It's kind of through random selection in the sense that the faculty have their teaching schedule, and then they decide which of their class which class or which classes they're going to implement this interdisciplinary collaboration in. So it's always been for architecture, our 2312, which is architecture technology. For biology, for 2023, it was anatomy and physiology 2. Before this past spring, it was general biology 2. And then for engineering, it ranges from graphics, dynamics, economy, and even circuits. And you can see, looking at the course numbers, we are able to reach students whether they're late in their time here at EPCC, like they're about to graduate, or we're also able to teach this to students when they're quite early in their time here at EPCC with the 1000 level courses. So how you would be a part of STEM FUERTE is, again, you can't necessarily join per se, but you just have to be a part of these classes, sign up for these classes with the instructors, and then they have to choose to decide to do the interdisciplinary collaboration in their particular class. Next slide, please. So when students join these classes from architecture, biology, and engineering, they oftentimes, like any other student in any other discipline, STEM or otherwise, they think about their disciplines as being separate. Okay, they just think about, I'm going to only study the title of this topic. So for instance, architecture technology, those students come into class thinking, I'm going to talk about architecture. And biology, they're thinking about, they're just going to talk about biology, and engineering the same. And so they think about these disciplines as being separate. But our goal is to get them to collaborate, because in the real world of STEM, as a professional, you're going to talk to a lot of people, and sometimes they're not even scientists themselves. Next slide, please. So thankfully, Professor Nora Cuvelier, she's also a doctoral student at UTEP, and part of her thesis work is focusing on something called systems thinking. And systems thinking is basically, we are taking the barriers and basically thinking about topics from a holistic perspective. So more formally stated, it's here expanding our awareness so that we can see relationships between all the individual parts that make up a system and how they relate to the entire system itself. What that system can be, you know, the world and everything that's in the world. So the professors help students develop a systems thinking mindset where they're able to look at the bigger picture. They look at the people in the world and how everything relates to itself and how it relates to the bigger picture. It's also looking at risk. Like when we're having these conversations about solving a problem from a biological standpoint, who's not being, you know, who's left out of the equation? Whose viewpoint is not being considered? So if you think about architecture, they don't just design buildings, they design buildings with people in mind, right? Or with engineers, they don't just design things, they design things with people in mind. And so we're helping students to, again, from the start, begin to consider other perspectives other than their own. And that's the way the real world of STEM works. Next slide, please. So once students are indoctrinated into systems thinking and how they have to think about other perspectives, instead of there being walls between the three disciplines, there are points of overlap and points of concern where these disciplines can work together to create something for the greater good of humanity. Next slide, please. And so how this is all encompassed or summarized is through something called the Lunar Living Project. And basically, again, we have a team of 6 students, 2 students from architecture, 2 students from biology, 2 students from engineering, and they're randomly put into teams by the faculty. And the reason why it's lunar living, because it was inspired by NASA's Artemis mission to the moon and Mars. And so again, these students in these groups, they are tasked with using a systems thinking approach. How can they establish a working human colony on the moon? And that's pretty much all they're given. Like, they're given obviously some support, but in terms of like the project, like what do they want to work on? Do they want to focus on nutritional requirements for astronauts? Do they want to focus on how they live? Do they want to focus on energy generation while on the moon, because there needs to be computers and so on and so forth? But the students, they get a chance in their groups to pick the scope of their project and what particular area they want to focus on. And so you may be thinking, oh my goodness, this is a huge undertaking for a student who may be a freshman or a sophomore. Maybe this is more suited to a graduate student. But one of the awesome things about our faculty here is that they anticipate every need that the students have, and they work to address those needs. And so let's talk a little bit about how faculty provide support to students as they're taking on this novel project with people they don't know, some within their major, some definitely outside of their major. How do they arrive to creating a project that they feel confident in? Next slide, please. So first of all, there is going to be faculty and peer support in person. So throughout the semester, there are several brainstorm sessions. So if we go from left to right in these images, starting in February, the professors put together a brainstorm session where the students can meet their teammates in person. Again, they're from different disciplines. Their classes don't even meet at the same time. So how do we get students to collaborate? We create these opportunities for them to meet in person, not only with each other, but with the faculty from different disciplines, right? Because if you're a biology student, you would probably have no reason to get to know the architecture professor, even though you're learning basic principles of architecture and engineering. And so faculty and students can come together in these sessions, and they had one was in February, starting with a brainstorm session. The next session was a plan and sketch session the next month in March, and then in April they had a create session, followed by late April a poster session. So in each of those sessions we provide refreshments, and students can come. It's voluntary, of course, we don't make them, and they can come and just get to know their team and begin to work on their projects and flesh out what they're interested in and what they want their project to focus on. Next slide, please. And so not only is there those in-person opportunities throughout the semester, there's also faculty and peer support virtually. We have a dedicated MS Teams page where the faculty basically invite to this Teams page all the students in the cohort. So that's the architecture, biology, and engineering students in one cohort. And so if we look at the image on the left, this is Professor Cavelier from engineering, and she's basically letting people know, hey, you've been accepted to this team. We've already put you in your assigned groups. Here's what you need to do. And so it's a way for faculty to share course information, get students involved socially, and communicate information about the course. Sometimes Professor Cavelier speaking to architects and biologists. Sometimes biologists are Professor Preza speaking to architects and engineers, and Professor Myers is speaking to he's speaking to biologists and engineers, and so on and so forth. So they're able to communicate and be supported and ask questions. And then if you look at the image on the right side, you can see this is an image from a student where the first student's asking, well, what time and day would you prefer? The students are orchestrating when they can meet so that they can work on their projects and begin to hash out ideas. And if you look the second thread in that conversation, you see somebody's asking about the effects of radiation on the body, because they're anticipating when you're on the moon, you have to deal with some level of radiation. So again, students are supported through in-person and virtual interactions. Next slide, please. In addition to getting a chance to get supported virtually and in person, we teach them additional skills. Two workshops that I present to students, I actually get a chance to show up and present, is plagiarism. A lot of students know about plagiarism because it's in the student code of conduct for EPCC, but it's a chance for our students to get a chance to really learn it from an applied standpoint, like how do you actually use this? You're not supposed to copy, but how do you use it? And so we give a workshop on that. And we also teach our students how to responsibly use ChatGPT and other AI programs. And we also teach them poster presentations. Okay, so a lot of students, they maybe have never put together a poster presentation before, and so we show them how to design a poster, what are some good presentation design principles, and then also how do you speak to people about your science. If you're a scientist, you can't just approach people with these big words, and maybe they don't know what an electron is, and you have to be able to explain that. So we teach them how to communicate with all levels of people who could come up to them when they're presenting their posters, which we'll talk about it in a moment. Next slide, please. And so the semester climaxes with the student poster presentation. It typically happens the last week of every semester on the VV campus in the AST building. And you can see from the images, we really go all out for the students. You can see at the top is the catering table that we put together. We start them off with sweets and salty snacks, and then we end up bringing in, really good lunch. And we have signs and balloons and all sorts of things just to make it mimic a real symposium presentation that they would go to, like if they went to an actual conference for engineers or architects or biologists. Okay, and so we ask each interdisciplinary team to make one poster, so the students also have to collaborate on, okay, what are we going to put on this poster? How do we tell the story of the project that we all decided to work on and that we designed? And then once the presentations happen, we also have our UTEP partners come over and serve as judges. So we have a lot of graduate students and professors from UTEP engineering and also other disciplines to serve as judges. Next slide, please. And so here are some images. Starting in the top left, you can see students are presenting, and the people who are seated, those are our UTEP partners who are serving as judges. The gentleman standing, that's Dr. Peter Golding. He actually wrote the grant, the FUERTE grant. Okay. Below that, we have pictures of the winners, first place winners from the spring 2024 poster session. In the middle, you see a young man. He's from engineering, and the requirements that for Professor Kuvelia for that particular semester, they had to make a working prototype of what they were going to be designing for living on the moon. And you can see a student working with his prototype. In the top right, you see somebody made a model of a moon rover, basically a vehicle to travel over the moon to transport items from one end to the other. And then in the lower right, again, just another group of students presenting their posters. And it's really exciting to see students, you know, in the beginning when we meet them, they're kind of nervous about having to collaborate. Oh my gosh, I don't know these people, to being super excited and super confident, because in that moment, they are the most knowledgeable people about that project, right? They put it together themselves, and they went and did the research and decided to create something brand new. And in that moment, they are the absolute expert on what they created. So it's just awesome to witness that confidence emerge over the semester. Next slide, please. Okay, so the next part, so the first part I talked about was the interdisciplinary collaboration. And now we're going to move on to another way that we help students, which is through skills building. And skills building is providing students those skills that they may not be able to necessarily get from taking class. Obviously, in class, there's content that has to be addressed, like making sure the math is on point, making sure the technological skills are on point. But there are other parts of the student that we want to build. And so we have a summer workshop series every summer. We call it the STEM Lunch and Learn. And basically, they're 1 hour meetings during weeks 2 and 4 of each summer session. So we just had one this week because we're in week 2 of summer 2. And during these sessions, we provide them free lunch, and then we present them workshops on a variety of topics. And the flyer is, that's what's showing here in this image, one of the flyers that I prepare for students to know which workshop is coming up, and also so that they can RSVP to receive lunch. Next slide, please. So again, the summer workshop series, it's also a chance for us to partner with other departments on campus. So we have partnered with Student Success Tutoring. In 2023, we had Ms. Della Truman and Ms. Janice DeWitt come and talk to our students about the resources that are available through tutoring here on campus. And then this past couple of weeks ago, we had Ms. Liz Olivas come and give that presentation. We've also worked with Career and Transfer Services, Daniel Rodriguez, Natalie Rodriguez, and Sergio Colleen. And then we have worked with this past, I guess 2 weeks ago as well, we worked with EPCC Mental Health Awareness with Carrie Van Hoot, Crystal Escobedo, and Fan Chin. We also work with Centers for Students with Disabilities, and that's in the picture, the picture on the lower right-hand corner. That's John Estrada. He is presenting for us from the Centers for Students with Disabilities. And then also we have EPCC Makerspace with Calvert Boyle. So again, some of these pictures from some of the workshops that we've had during the summer, which students appreciate, again, learning how to write a resume. So with the Career and Transfer Services, we had them come and talk briefly to students about what principles they need on a resume for STEM majors. And then by the time the workshop was over, students were able to leave with a working resume that they could then add on to. So it's really cool for students to go from nothing and then leave with a working copy of a resume that they could just edit every semester to showcase who they are professionally. With the mental health awareness, that's particularly important because, again, we're acknowledging the whole student, and students have a lot of stress with their lives, working, family concerns. And so the team from Mental Health Awareness taught students about being mindful, how to be in the moment, how to manage stress, different breathing techniques. And I even learned something myself. So I'm like, I need to make an appointment with them so I can learn more strategies for coping with stress. And then, of course, with Makerspace, we help students. A lot of our engineers and architects they build models and prototypes, and the Makerspace has free resources for students to use to do like 3D models, and they can do the 3D printers. Everything over there is free for students to use. And then with Centers for Students with Disabilities, we talk to students. A lot of students do have disabilities that they may not even know of. And so we kind of talk to them about what resources are available to them. And then for those students who may not have a disability, to serve as allies for those students who may be in their classes who have disabilities. Next slide, please. So the third part, third 3 of 4, so you can see kind of we're getting towards the end, is articulation. And articulation is just a fancy word for what are we preparing students to do with their life after they get their degrees from EPCC. And so the options are they can continue their education at a 4-year institution, or they could go straight into the career workforce, into the workforce as a STEM professional. And so as you know, as I said at the beginning, UTEP is our partner in this grant. We interact, we meet, we try to make an experience that's really good for our students so that they feel empowered to be STEM professionals. And so a lot of our articulation towards 4-year institutions will be through UTEP. Next slide, please. So one of the first things that we tried to do was bring, we know our EPCC students are busy, so we thought to bring UTEP STEM student organizations over to EPCC so that our students could see who their peers are going to be should they decide to continue their education on at UTEP. And so we brought, in the top left corner is SHIP MIAS. SHIP is the Society of Hispanic Professional Engineers, and MIAS is, it's now MIAS, Latino Americans in Engineering and Science. It used to be Mexican Americans in Engineering and Sciences, but they added the Latinos, Latino Americans in Engineering and Sciences to encapsulate that all of our students may not have, lineage to Mexico. They may be people from other countries who are Spanish speaking or who fit the Latino classification. But anyway, these two organizations serve to help support students who are in the engineering track. Okay, we also had in the middle, we had the Society of Physics students come out, they call themselves SPS, and they came over to talk to our students. And then also we had Club Zero, which is the math club over at UTEP. Next slide, please. And not only did we bring UTEP STEM student organizations to us, we actually, every semester, we take our STEM FUERTE cohort students over to UTEP so that they can visualize what it's like. A lot of students, we found out, even though we're all in El Paso, UTEP's in El Paso, we're in El Paso, a lot of students hadn't stepped foot on UTEP's campus before. And so we wanted to say, okay, we're going to make that, create an opportunity where students can go and begin to feel comfortable about, on a place where they may potentially continue their education. And the vast majority of students at UTEP, they do transfer from EPCC. So it was worth our while to make this happen every semester. So in the image, we're showing some EPCC students at the UTEP mock hospital. The mock hospital is just what you would expect it to be. It's you can see in the picture there's a mannequin, and these mannequins are actually like robots, and they can make these mannequins mimic a whole bunch of medical events and release bodily fluids with computers, so that students who are in the health fields can learn how to respond. If they're in nursing, they can see exactly how that responds. If they're planning to go to med school, they can again go in there and see how an instructor is behind the robot, can tell the robot to fall off the bed, and the student would have to respond. And so students are again taking a tour of this facility. Next slide, please. Also, you can see EPCC engineers standing outside the College of Engineering on UTEP campus, and that's Professor Cuvelier out in the front. And then you can see in the bottom picture, Professor Clark Myers taking the architecture students to the Lakong Temple. It's the temple inspired by, I think it's a Bhutanese temple. And so obviously they want to study the architecture because it's quite unique and beautiful. And so the architects definitely want to go there. So not only are we taking students to UTEP, we're taking them on customized tours that fit their majors. Like engineers would go to NASA and aerospace labs, just things that are suitable for engineering. People from biology tend to go to the mock hospital. And then of course the architects have their own, they want to look at the temple for sure. And then they all get the chance to go to all the different exhibits, but we do try to customize it based on what they're most interested in. And when the architects go to the mock hospital, they're actually able to look at the floor plans and see how they design the space to be used for those students. And also while the students are there, they get a chance to interact with the STEM student organizations. We have lunch with them, so they get a chance to hang out with the honey badgers. That's the video game club, I believe. They get to code video games. They get to see, obviously, SHIP and MIAS. They get to see Club Zero, all the clubs that they saw when they came to EPCC campus. And then they also get to meet with admissions and financial aid. And it's cool because we've been going now for the past 3 semesters to UTEP every semester. And so now we get to see students who have left from STEM FUERTE, and now they are actually at UTEP as bachelor students. And when we come and we take our tour, they're actually serving as tour guides, talking with students who are EPCC students. So it's like they were once where our students are, and it's just nice to see them go on and do what they dreamed of career-wise. Next slide, please. All right. In addition to helping students think about transferring over to UTEP, we also take them on industry field trips. And in this picture, you can see Professor Couvelier out front. And she took her students to visit Prod DNA. It's basically a company that focuses on engineers. And also they visited Amazon, but you know, they weren't letting us take pictures there. So you'll just have to take our word that we visited Amazon. But they were getting a chance to talk to Amazon and see like what opportunities are available for engineers. Next slide, please. Okay, the final thing I want to talk about is something that we tried, one of our final program aim, which is sense of belonging. And the definition of sense of belonging is just basically feeling like you are seen, valued, and accepted within a group of peers, by your peers and your mentors. Okay, so a lot of students, when they come to college in general, regardless of racial or economic demographics, sometimes they can feel like, wow, I didn't belong here. But if you're first generation, that feeling can sometimes be even more so overwhelming. And so our goal is to help students, no matter what their background is, where they come from, their level of preparation, whether they were honor students or not honor students, to help them to feel like there's a place in STEM for them to grow and thrive. And it shows that when we help students feel like they belong and that they fit within this group, that students are more likely to retain. We talked about this leaky pipeline at the beginning. And so if students feel like they're supported and they're valued and that they belong, they're less likely to drop out or switch majors, or more likely to stay with STEM. Okay, and also when students feel like they belong, they are more motivated and their grades improve and their mental health has shown improvements according to several studies that are out. And this is particularly important for STEM students. Sense of belonging can impact all students, but it's particularly important for STEM students because the classes are perceived to be, you know, more difficult than maybe other disciplines. But if you know anything about college, everything is challenging because you're growing and you're learning. But specifically for STEM students, sense of belonging has been shown to be particularly important for their sense of well-being and their ability to want to finish out their degrees. Next slide, please. So we talked about before, we have support, but not only when we have these in-person sessions throughout the semester that students feel this support, they're also getting academic and social interactions. So while they're brainstorming and planning out their posters and projects, they're having food, they're laughing, they are engaging. And also, if you see in the image, the furthest to the right, the professors put together a STEAM movie night where you have your science, technology, engineering, the A stands for architecture in this case, and then math. They put together a night where they can watch a movie called The Martian. Obviously, since we were focusing on lunar living and being in space, it was pretty cool for students to watch a movie called The Martian, just a space movie. There is no quizzes or tests, just getting together to have some popcorn and drinks and just have fun with each other. Okay, next slide, please. And here's a picture of one of the collaborative sessions. They were invited to the architecture building, that's Building Z. I don't know if you've ever walked in there. There's a sign on the stairs that says, no architects beyond this point, but we were all welcome, regardless of our discipline, to come there and have a collaborative session where students, you can see in the pictures, that room was filled. And I don't know, you can't pick out the snacks because the images are a little bit too small, but we brought in food. And again, students were able to come and meet with their teammates. As I told you before, the classes don't meet at the same time. And what was really cool about the students' dedication, and it also kind of attests to how awesome the professors are, because one of the professors was out of town, and the other in their class met at a completely different time than this collaborative session, but they came. Several of the students from this discipline came to the session, and so it's like, okay, your professor's out of town, and this is not your class time, but yet you drove all the way here to be a part of this. It speaks to how awesome the experiences professors are giving and how awesome the students feel about being a part of this grant. Next slide, please. Also, as far as sense of belonging, we also use the Teams page for peer support. Sometimes students are feeling alone, or they're feeling like, oh, if I say this, am I going to be considered, I guess the worst thing, sometimes people feel they want to say the nerd, but we're in college, we're here to learn. Nerd is a good word, right? I hope so. But in this particular image, you can see a student, and they're posting a link about how well does concrete work in space. So students are putting in links and sharing different ideas and things. You can imagine, you think about on Earth, the gravitational constant, the pull of gravity on an object in Earth is 9.82 meters per second squared. So what is that variable when you go on the moon? Obviously, gravity is not the same on Earth as it is on the moon. And so this student is posting a link on how they can consider working with concrete, even though the gravitational constant is quite different. It's actually quite a bit less on the moon. And so, again, students are supporting each other. They are communicating with each other, letting them know we're all on the same team and we're all trying to win in our individual groups and collectively as a team. Next slide, please. So let's talk about what's next. So just kind of to summarize briefly, we help students collaborate, we help them prepare for their future after EPCC, and we also deal with the whole student, helping them feel confident mentally, professionally, to put themselves out there to get a job or to go on to get a career. So what's next is, starting in the fall, we will be opening up the STEM FUERTE Student Lounge. It's on the VV campus in A2732, and you can see the picture on the left is what happened after physical plant did demolition of that room. And then you can see on the right what it looks like today. And so this is going to be a place where students can go and build community, and a place where they can go and have that sense of belonging, have a chance to collaborate on their projects. It'll just be a space for them. There are 6 computers that have double screens, and all the computers are outfitted with all the technology and all the programs needed for architecture and engineering. Biology didn't have as many requests, but we can always put in a work request. So we thank Physical Plant for helping us to remodel the space and outfit it for students. Next slide, please. Also, what's next is we plan to bring on in August, fingers crossed, a STEM academic advisor. And this is going to be in collaboration with Ms. Sandra Lujan, a first-year experience. STEM students require a lot of support. Like, can you take 18 hours in one semester if it's like physics 2, organic chemistry, and calculus 3? Can you do all that in one semester and still be okay? Well, I don't know, but the STEM academic advisor will help students decide and put their classes together, help them think about internships and co-ops and all of these different activities to help develop them professionally and personally while they're here at EPCC. So after that, we'll figure out what comes next, but we're just really grateful for how far the project has come and also where we plan to go in the immediate future. Next slide, please. So obviously, STEM FUERTE, it's a team. I am the project director, but I definitely couldn't do this by myself, and so I'd like to take the time to acknowledge a couple of people. First is the faculty co-PI team. They're the ones who are teaching students about systems thinking about how to collaborate and talk about their science to other people. So Clark Myers in architecture, Elizabeth Preza in biology, Nora Cuvelier in engineering. And prior to Elizabeth joining us, we had Glenda Hill. She's the biology faculty coordinator from 2021 through 2023 with STEM FUERTE. We also have to thank Dr. Rebecca Escamilla. She's the Dean of Arts, Architecture, Math, and Science, and she's also the budget head, and she really helps us in so many ways, too many ways to name here. We also want to thank the grants management team, Jesse Ariano, Hilda Diaz, and Bob Elliott, because they make sure that we are in compliance. And then our many UTEP partners, Dr. Peter Golding, Dr. Diane Golding, Helen Geller, Dr. Claudia Lopez, the whole team over there. There's so many people we work with, and we appreciate them. And finally, we want to thank Ana Torres. She served as the administrative assistant from 2021 to June of 2024. And so it has been a team effort to get everything going. And I feel like I'm the lucky one because I get to take what maybe our faculty say and turn it into something more and figure out how to make it happen. So definitely blessed to be here. Next slide, please. So if you want to contact me, you have any questions, how you can be involved with STEM Fuerte, you can call me, you can email me. My information is there on the screen. And then next slide, please. And then I want to thank you for your attention today, and I'll be happy to answer any questions that you have.
All right. Any questions, anybody? Well, while y'all think on those questions, if you happen to have one, please raise your hand or post in the chat. And if not, I'm going to go ahead and I'll move on to sharing next week. All righty. Let's see. Okay, I don't see any questions, so I think I'm safe to proceed. I'd like to take a minute to thank Dr. Jamison for presenting for us today. Thank you, Dr. Jamison. We appreciate you. Thank you for showing us what STEM Fuerte had to offer. And then I'd like to invite everyone back next week, same time, same place, on July 26th. For Happy Math Hour, we'll be in this room for Math 1314, linear and nonlinear systems. For Math 1324, we'll be going over the Exam 3 review. And for the 1 p.m. session in this room, we'll have the EPCC Writing Center with Vanessa Zuniga. I want to take a moment to thank you all for coming today, and we hope you have a wonderful weekend.